Good morning, students. Welcome to today's session on active solar space cooling system under the course Renewable Energy Resources. Course code being 216652 for 21 batch scheme. Myself, Dwarkanath SK, Assistant Professor, Department of EEE, SJB, Bangalore. Let us go to the today's topic of discussion on active solar space cooling system. So, looking at the figure over here, so from the sun rays which is falling onto the solar panel systems, from there it is going to the heat exchanger. From there to the turbine, condenser, back to pumping. This is a closed loop system. From there to the condensation, from the condenser to the exchanger, so expansion way. So here we can make use it for the cooling system. So this solar space cooling is quite costly to implement, but best for the solar system which serves more than just the cooling, but to maximize the returns on the investment and not to leave the system idle when the cooling is which is not required. So significant space heating or that of the water heating, this can be accompanied with the same equipment which is used for the cooling, solar cooling system. So heating purpose and also for the cooling purpose which we can make use of it. Active solar absorption cooling system which is presented as shown in the figure above here. The sequence flow is there. Heat from the solar collector which separates a low boiling refrigerant into a generator which receives a pressurized refrigerant from an absorber. So solar heat, this can be used as the operation stage of the cycle. Here you can see different modules like a generator, condenser, evaporator, absorber, pumping system from there to liquid heat exchanger back to the generator. T1, T2, T3 is a different temperatures which is passed on to the absorber. From the absorber to the pump is T4 system. From pump back to the liquid heat exchanger T5 system. From T5 to T6 to back to the generator. From generator to condenser T7 system. It is passed on T8 from T8 to T9 to the evaporator back to the absorber. So input to the generator is being the solar heat. So this we call it as the schematic of the solar absorption cooling system. So various modules which are available are in the market type: compound parabolic based solar collector, Fresnel solar thermal collector, and usually in active solar cooling system, this fluid which is provided, which is make use of fan or pump and power which is necessary for this purpose. Process kind of it. So these systems have an high efficiency but may not be more economical in case where especially when the lot of power which is required for the cooling. So in a passive cooling system, so there is no additional power requirement of it. So cooling techniques for the power. So researchers, they have constantly been trying the new methods for cooling the solar panels. These methods can be classified into various ways such as like a liquid based, air based, PCM based, so on. So in addition, nowadays is frequency used in the hybrid system which has a different application altogether usage. So when we look at the literature, different cooling systems which are available, which is as shown in the figure, which is available in the next slide. So cooling of the solar panel which is available of type air based or PCM based system, heat piping system, heat sink, fins, radioactive cooling system, micro channels, nano fluid based channels, spectrum filter, thermoelectric or refrigerant based, evaporative, hybrid modes, liquid based or air. So these are different cooling techniques which are available in the solar panel. Hope the session was very much useful by watching. So do subscribe for the department YouTube channel. Any queries with respect to today's video, you can reach out to advarkanet@sjvt.edu.in. So thanks for watching.